I'll send it by this week. By tomorrow or day after tomorrow, I'll send something like that. Okay. Okay. Any other questions from last day?
Sir,
Okay. Yes.
sir, can you please give us some more examples regarding that get car and put car functions?
Just yes, I'll do it today also. I'll do it today. I'll do it today.
Okay, sir.
Yes. Yes. I'll take up some more examples today also. I'll take 1 or 2 examples today also. Okay. For get that. Anything else? Any other requests? Okay. Today's objective is we'll take up last day what we had done. We had basically checked up your counting of the number, counting of the words, characters, right? Today, what we're going to do, we're going to extend that program. We're going to count the words, I'm going to count words, I'm going to count characters, I'm going to count numbers, right? I'm going to count any other symbols which are there. And also, what I'm going to do is basically I'm going to, I'll assume that between each character, between each word, there is a simple, there is a single character, a single, what do you say? As many number of blanks you give, that many number of blanks you connect. So I won't check for the grammatical conditions. So there will be no grammatical conditions which you check. Okay. So can everybody see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Let's start off with something. Okay. So I require counters, right? So let's say I have got counters for C count, right, which is a character count. I will be having for number count. NMC. Huh? Yes. Hello. Is there any question? Number count. I'll have blank count. I'll have a blank count. Then I'll have other character count. Okay. So char count t will be 0. Num count will be 0. Will be 0. So other this will be 0. While I'm actually writing the programs, please note how actually I'm writing. And you can see in line number 7, I have written all these things with semicolons in one line. So it's the same thing as writing in the same line. Okay. Rather, there is something called see. There is something called, there is a website. I cannot find the programming right now. It's basically ubiquitous C programming is basically writing some sort of structures. It's actually a challenge also. You actually basically, the challenge is basically you have to write programs which nobody can decipher. So how you're writing the style of the writing of the programs is something like no other person will actually understand how you're writing it. Okay. So there are some programs, when I've seen some programs over there, all the statements are written in one single line. So those are allowed because technically what is actually happening, statements are actually written by all the statements are written in one single line. Okay. So if I actually do this thing, this is also right. This is also right. But for what we do, why we do all these stuffs is basically to actually help us to read our better, for our readability. Okay. So I'll be reading another character. Okay. So I'll be having something like this also. Char character. So I'll read these characters one at a time, and I'll check these characters whether they're a character or they're okay. Characters. What are the characters? They can be either a small a, capital A. Okay. Between small a to capital A, small a to small z, or capital A to capital Z. So these are my characters. Okay. My numbers are basically between 0 to 9. My blanks are blanks, and my others are basically all my symbols. So basically full stop, semicolon, and exclamations, and even maybe other some hash, dollar. All these symbols, all these all these symbols will be my other characters. Okay. But then at the end of the day, as I was basically harping on last day, it will be, there are only characters. So I can interpret these characters as ASCII codes. They'll be writing. They'll be between 0 to 255. Okay. So all these numbers, all these symbols, which we are going to go over there, which I'm going to input, they are all ASCII codes, and they all lie between 0 to 255. Okay. So I don't have any option. So so what I can do is basically while character is equal to get char is not equal to UF. So this is the same thing what I have done. Last, if you remember, I had used my, so I'm going to read the get character. I'm going to read my character, and I'm going to go on reading it till I do not get an UF. That is my end of file. End of file is basically is a macro which is defined in str.h. Okay. By default, the value of UF is -1. and my my end of file for Unix systems is Control D, and for my this thing for Windows system is basically Control C. Okay. Okay. So now I want to check what my characters are like. Okay. So over here, what I'm going to do there are two ways. Number one, if I can write something like this. So I can start something like this. If my character, I believe I have to basically shorten this thing. RC is equivalent to a blank, then I'm going to basically increase the count of my blank character. So BLNK CNT plus. Now, lastly we had basically okay, let's say go something like that. I'll just so if my I'm just going from CHRC. So if CHRC, I want to check whether it's whether it is a character or not. So if CHRC, okay, how many of you, all of you are aware of the Boolean functions? How many of you are not aware of the Boolean functions? I just want to know. How many of you are not aware of the Boolean functions? You had it in class 11, 12, I believe so. Hello?
Sir, I had a bio background, so I don't have an idea.
Okay.
Yes, sir. Same goes with me.
Okay. So this is what I'm going to do. You are all having basically electronics, right? The digital part they have actually followed.
No, sir, they have not followed yet.
Okay. What we are going to do is basically we are going to work with logics over here, right? Now, I think that my statement should be something like this. I want to check whether my number, whether the character which I'm coming out, it is between some characters or not. So I want to check whether my character is between small a and small z, right? Or if my character is lying between capital A and capital Z. If I want to basically check it by an English language, right? So I want to check whether my character is lying between small a and small z, or is it lying between capital A and capital Z? Okay, let's check this line number 11. Let's check this line number 11. So what happens if my CHRC is not equal to a blank? What will happen? What will happen? What does it actually imply? Tell me. It implies whether the statement is a true or a false. So CHRC equal to blank, I can only state that this states that this statement means this is true if CHRC equivalent to space, else it is false. Right. So my condition CHRC is a blank. Either it can be a true condition or it can be a false condition. Okay. Any question? Any question over here?
No, sir.
No, sir.
No,
Okay.
sir.
No, sir.
So if
No,
I
sir.
say that this is a statement, I can say that this is a statement. So I can have multiple statements, and these multiple statements joined with some other logical connectivities. These logical connectivities are what we say to be as logic connectivities, Boolean logic connectivities. So Boolean logic connectivities, I can basically, let's say, what do you mean by logic? So logic, it says that it's concerned with ways in which new sentences can be constructed from given sentences, and with the deductibility relation between these sentences. So I can have different statements. So let's do Ram is a boy, okay, and Ram is studying in Jadavpur University. So if I want to join these two statements, what will I say? Ram is a boy and he is studying in Jadavpur University. So that and becomes a logic, or it becomes a connectivity, and it basically deduces to these two sentences in such a way that it brings in a new sense. So the principal task of logic is to basically determine which follows from other sentences. But when do I talk about logic in mathematics? Okay, it was actually formalized by basically De Morgan and George Boole. When I'm saying with logic in mathematics, we have got what we see as propositional logic. This is also known as sequential logic and statement logic. It is a branch of that studies of joining and or modifying entire propositions. So propositions are what? A statement is said to be a proposition. Right? Statements are said to form more complicated propositions. Statements are logic. So in my condition is that one of my proposition is CHRC is equivalent to blank. So this is a proposition. This proposition can give me this proposition will help me to make me a decision. And it will also basically help logical relationship and properties that are derived from these methods of combining on alternate statements. So let's say the logical connectivities are basically my and or my or. They are and or my or. Okay. Let's say what can be a statement, something like that. Let's take for example a statement. What is the proposition? A proposition or a statement is a declarative sentence that can be either true or false, but not both. Right. So over here, CHRC equivalent to blank is actually a statement or a proposition. It can be either a true or a false. Even if you see actually this statement, CHRC is equal to get car. Right. So is it a end of file or is it not end of file? So this is one proposition. This one whole stuff is a proposition. Mind it, this is an assignment because it's an equal to. So this is an assignment. Whereas this whole statement is actually a proposition, which tells you whether this position is true or false. Okay, so the value of the proposition I is called as truth value. It can be denoted by a true, or if it is a false, it is by F. For example, what can be said is a declarative statement. So Calvin is a math major. This is a statement. Do you have a barbecue sandwich? So this either the answer will be true or a false. Yes, I have a barbecue sandwich, or I do not have a barbecue sandwich. But this is an imperative sentence, or in order to do something, eat your vegetables. This is not a basically this does not have your basically true or a false value. So this is not a proposition. Okay, so now I'm going to connect all these propositions. So what are the ways of connectivity these propositions? I can have a negation, I can have a conjunction or a and, negation or a not, I can have a disjunction or a or, I can have a conditional, that is if then. I can have a biconditional, so if and only if. I can have a biconditional, if and only if. So technically, basically in my programming language, I will be using these the first 4. The first 4, it will be very important. So my negation is something like this, is not equal to. So my negation can be something like this. I can also negate this thing as something like this. So this is my negation. So this is my negation, right? Just hold a second. My full statement. So this is my negation. So this is my statement. This is my statement, which is an equivalent to, okay, I want to negate it. So my exclamation tells me which is a negation. For C programming, my equivalent is basically double equals to, and for negation is basically an exclamation. So these two statements, this statement and this statement is actually the same thing. Is actually my same thing. So this is again a proposition. So it gives me a either, so this statement, this whole statement, CHRC equivalent to blank, it gives me either a true or a false. So if I say that my CHRC is actually a blank at any one time, that if true, so this is also equivalent, I can say. So if CHRC equivalent to blank, then this is equivalent to if this is equivalent to if true, then do something. If true, then do something. So this CHRC equivalent to blank, this basically statement, when it says it's a true, that means it's true, then the blank BLNK CNT will actually work. If it is a false, then it will not work. Okay, so now all these statements, can be, I can assume all of these statements to be a variable. So P is actually a John is tired. P1, I can say John looks like tired. So Q is basically, I can say Aduna is patience. Q1, say I can say Mohan loves mathematics. So my P1, Q1, these are what we say to be a statement variables. So I can assume in one way, I can have basically a variable over here. I can have a variable over here, which gives me a 0 or a 1. So let's say, so let's take, for example, int bool value, right? So bool value equals to so let's say what actually this looks like. So GCC so it gives me a 97. Bool value, sorry. Sorry.
Excuse me, sir.
Sorry, this one will be CAD is basically
Sir, here
yes.
CHRC equal to A will return either 0 or 1.
Yeah,
That will be
yeah,
assigned to bool value.
yeah. That will be assigned to bool value.
Okay, sir.
So this is the one, right? So if I give this a B, then see what happens. See? So these are my two results. Percentage D, percentage N. And just I can again basically do this thing. Let's see what will happen. Okay, so this will be a better one. Yeah. See, I have assigned CHRC to be an A, right? Now I'm asking the question, is CHRC equivalent to B? So this one will become a 0. This one will give me a false. So the false by default in my C program, in my C unit system is basically a 0. So this one will give me, so the bool value will be assigned the value of 0. Again, I'm basically asking, is CHRC is equal to A? Because CHRC is actually in A. So this one will give me a true value. Bool value will be assigned a 1. So my CHRC equivalent to B, this is actually a statement. This is an assignment. My line number 10 is an assignment, whereas my line number this 11, CHRC equivalent to B, this is a statement, including line number 13, CHRC equivalent to A, this is also a statement. So my statement actually tells me, since it's my statement, it always basically it's either a true or it's a false. It's either a true or it's a false. Okay. So in the same way, CHRC, okay, one thing you should be noting that all my assignments, they give me a true value by default. All my assignments, they are by default because assigning is actually true. So when you are assigning some value to a variable, that is always true. So if actually basically in my line number 18, if I actually basically change this system to an equal to, so this will always give me a true. This will always give me a true. Okay. So, but this statement will either give me a true or it's a false. Okay. Any question here between a statement and Boolean value?
Sir, I had a question.
Yes.
Sir, we are assigning bool value as a variable, and then we are using it to state either our statement is true or false.
Yeah.
That's why we are getting that one, the answer. But we are not assigning any value, like what value should be true. Like it for true, it can come out to be 2
By
or 3
default,
or anything.
by default is basically this is basically defined in, right? That is a 1 will be a true and the 0 will be a false.
Okay, then that's by default. We cannot change
that
it.
is right. That you cannot change it. That you cannot change it.
Okay,
That
sir.
you can. Actually, truthfully, no, we cannot change it. Sorry, no, we cannot change it. This will be fixed.
Okay,
So the thing is that since we do not know, so we just basically keep it my statement something like this, as in line number. Let it come as it is. So if it is by true, if let's take for example, in working in a certain system where my this becomes my opposite, so 1 becomes my true and 0 becomes my false, that hardly will matter actually, because if it is true, if it comes to basically a 1 to be as a false, then it will basically assume, or it will actually compile in that way only. Your processing will be done in that way only. Output will not matter over here. The net output, it will not matter. Okay, so by default, we understand that basically 0 is to be a false and 1 is to be a true. By default, that is what we understand. Okay. Any other question? Okay. So I can basically combine these statements, right? So these are not statements. To close the door, do what is the time, you must read this book. These are not statements. So what do you talk about how do we actually combine these logical connectivities? So logical connectivity, the most connectivity is basically my negation, my conjunction, or my disjunction, right? So negation is basically, this is my negation. This is my negation part. This is my negation. Okay, so exclamation actually negates. I have got a conjunction and I have got a disjunction. So all these conjunctions and all these follows basically some truth tables. So I can write something. If A is a statement, then not of A can be written like this thing, this symbol. Negation of this is this I'm talking with respect to basically digital logic or Boolean logic. When you will be studying maths with Boolean logic, Boolean algebra, you will actually know all these stuffs. You will come to know all these stuffs. Even in your system, in your course, you'll be having digital logic as far as I know. So when you will be studying digital logic, you will again study all these stuffs. So, but I require these things to be known to you because of this thing. Now, I have got a truth table. The truth table actually states that if my statement is a true, and on that statement, if I actually if I actually run my my operator, that is my negation of in this case, then what will be my, so negation of a true will always be a false, and negation of a false will be always be a true. So in this case, in my line number 17, so if char get card, so what it actually defines to be is char get card, CHRC is being assigned the value of money by getting from get char, and CHRC is checked whether it is to be an UF or not. Is checked to be either UF or not. So if CHRC is equivalent to a true value, but if it is actually a UF, then it will give me a true. Now my condition can say something like that. I can actually say something like this. Okay, I can say something like that. So if my CHRC is equivalent to an UF, yes, it is UF. Now if it is an UF, then obviously I do not want this to be done, everything. So I want to negate it. So I'll negate it. So my CHRC will be an equivalent UF. If it is a yes, then it will give me a false. So my while statement, this whole instant, it will give me a total false. If it is a false, then it actually comes out. It actually works. So CHRC is not an UF. If this is basically, if the value which is assigned is not an end of file, so it will not, it will be basically giving a false. So CHRC is equivalent to UF. If CHRC is not any other end of file, it will give me a false. So not of my false will give me a true. So while it is true, then my system works. Then my system works. So I can have something like this. While 1 so what do I state by this mean? 1 is always true because it's actually a constant. Anywhere it will not be a false. It cannot be a false because 1 is a number, it's a constant. So my question is 1 a 1? Yes, it is always a 1. So in this way, line number 16 actually gives me an infinite loop. While 1 actually gives me an infinite loop. Okay, so I can have something like this. So you can see actually, I'll just show you. Printf. slash n, you can actually see what's going to happen. See, it goes on and on. So this is what we say to as an infinite loop. It's not ending. It's not ending. Okay. So while one is an infinite loop because one is always a constant, which is always true. Okay. The conjunction, that is the AND function. This AND function. So A and B. The truth table is basically given by A and a B. So if A is a statement, B is a statement, both of them are true, then it gives me a true. If any one of them is a false, then it gives me a false. If any one of them is a false, it gives me a false. For writing of two statements A and B, so I will be writing it as A ampersand B in my C programming, where A is the statement, so I can write something like this. So let's take for argument's sake, so let's take for this statement. My question is A equivalent to B and A equivalent to C? Technically, you can have it's not possible because any variable cannot have the same value which will be basically which is basically having the same value at the same time. Okay, let's say something like this. A equivalent to B and C and B equivalent to B equals to C. Let's say, for example, this thing. Okay. So let's say this thing. So my thing is that in line number 2, what will happen is A equivalent to B. So this will give me a true. And so this is a true, and B equivalent to C. This is also a true. So true and true will give me a true. Right? That is the truth. So if both of them are true, then what will happen is that my consecutive statements will actually work. My statements will actually work. But if this one is this thing, so what will happen is A equivalent to C. Now A is actually A is not equivalent to C. So A equivalent to C will give me a false. Okay, now what is the condition for AND statements? So if any one of them is a false, it will actually come out. So what it checks is that the first one is a false. It actually does not check the second one also. It just comes out. It just comes out. So I can have as many statements as I want.
Sir,
Yes.
it should be a true statement because we have assigned A the value of B and B is already equal to C. So
No, sorry,
this
A is a variable, B is a variable.
B is a constant because we have already assigned the value of C to be that of the value of B.
But even though it's a constant, it's actually a variable.
Yes.
Right. So A is a variable which I have assigned B. Okay. Okay. Let's get over here then. Let's do this thing. Let's this thing. So CHRC is equal to A. And let's say, for example, CHRC1, CHRC2. Okay. So CHRC1, CHRC equals to B. Right. Now, dual value. So my condition will be this thing. If, right, so print So thing is that if my CHRC equivalent to A and CHRC 1 CHRC 2 equivalent to B. So So, can anybody tell me what's going to happen? So in line number 18, what's going to happen? CHRC equivalent to A. So this is true. Once it's a true, it goes for the second condition also. It checks for the second. So CHRC is going to equivalent to B. So this is also true. So true and a true gives me a true. That means, so this statement will actually work if true or if 1. Because what is my true value? It's a 1. So this one will give me a 1. So if true value, then this will give me a 1. What about this? What about this? So CHRC is a B. I'm asking if CHRC is equal to B. Now CHRC 1 is actually an A. So this one will give me a false. Line number 21, this statement, CHRC 1, this one will give me a false. Right? So what will happen? If my first one is actually a false, it won't even go for the second one also. Because it states that a false with a true will give me a false. So my thing will be basically it's going to come over here as hello. So let's say what is going to happen.
স্যার ওখানে CHRC 2
CHRC 2 হবে
Okay.
অ্যাসাইন করেছেন
line number 16 CHRC 2
There's another problem. You see, hello 1 is only being printed. Hello 2 is not being. Okay. আমি এটা এরকম ভাবে করতে পারি. So I have got a bool value. Let's see actually what they are. Bool value equals to there. So my first one is a true, which gives me a 1, and my second one will be as false. Okay, any question here? So this is basically my negation and equivalency. This is my AND logic. I'll go for my OR logic right now. So what am I OR logic? OR logic is basically A or B, and if any one of them is true, then my logical connectivity is basically A or B is basically true. Else it is a false. Else it is a false. So any one of them is basically a true, then I'll be having it as a true. Okay. So for my working to be as an odd function is my two pipes. The pipe symbol is just this behind the basically backslash. Okay. So so let's see another thing. I'll just show you one thing. So check the first line. That is this. The first equivalence is 0. So this one is the bool value is basically a 0. See the negation of the CAD of A. So this one is actually a 1. This is basically a 0. So the negation of 1 is actually a 0. Okay. And this one is a false. First one is a true. The second one is a false. Whereas you can see this one. I require basically another total false. Yeah. So the first one is a thing. So check the other part. Let's check the other part. So bool value. So this statement is line number 28. The first one is basically is a, and the second one is also true. So true and a true gives me a true, right? No questions asked. Then the first one is a false, and my second one is a true. So if my first one is actually a false, it checks basically the second one. Now what happens is my bool value basically the odd function states that if it's an odd, if any one of them is a true. Now for my first statement, that is line number 28, since CHRC equivalent to A, it is a true. It does not actually even go for the checking for the second one also. So this is basically a disadvantageous part. So if you have to remember that if in my Boolean conditions, for my for, if the first is actually a true, it does not check for the false, just does not go for the checking for the second one. In the AND logic, if my first is a false, it does not even check for the second statement also. So it actually tries to optimize its own computability in such a way that it actually tries to minimize my condition checking. Okay, so the second one is actually a boolean. This is a false. Now, since this is a false, it will actually go for the checking for the second one also, because he has to know whether this is true or a false. So the second one is a true. So my statement says that. Sorry, where is my counting? So my statement says that if my first is a false, but the second one is a true, it gives me a true. Let's go for the third one, that is line number 32. So CHRC equivalent to B, so this is a false. And CHRC2 is actually also a C, this is also a false. So this gives me a false. And these are my outputs. So this is my third one. Okay. Any question? Any question? So I can combine my conjunctions on my statements. I can combine my conjunctions on my statements in such a way that it can bring in many other these things. So I can have something like this. You don't require conjunction. You don't require all these stuffs. So I can actually basically normal format. Let's see. So these are my, it works like something like this. So these are my axioms of my Boolean logic. So A conjunction, basically T gives me an A. These are my identity laws. What I'm actually trying to go for is basically I can have, just show. Yeah, you can see something like this. So this is line number 4, right? If A stands for John is tired and B stands for John looks tired. So A conjunction basically the negation of B. So John is tired, but he does not look tired. John is not tired, and so my fifth one gives me something like this. John is not tired, but he looks tired. So my or will be basically as given as a but or the word or. So I can have, in one way, I can join many conjunctions together, many statements together to form one Boolean value, form one Boolean function. Okay. So Control C, Control N. So I will just go for this one. Okay, so we'll come back to the first problem which we are working with. So my statements, I want to know right now whether it's a character or not. So my character or not, so I will be doing something like this. So if character is greater than equal to small a and CHRC is less than equal to small z. So why I'm actually using now, why I'm using these statements, this less than equal to or greater than, because these are technically, these should actually work with numbers, right? But then this small, when these things, these are ASCII characters, ASCII codes. So by default, when I'm going to work with this stuff, what is going to check is basically it's going to check with respect to the ASCII code of A, right? So the ASCII code of small a is as far as, I forgot the code, sorry. Okay. So if my CHRC is greater than small a and CHRC is less than small z, then my statement will work. But unfortunately, I also require that it should also do the checking for my capital character also. Right. So I require something like this. So it is an OR. CHRC is greater than equal to capital A and CHRC less than equal to capital Z. Then my CC and T will be a plus plus. Okay, so let's check these, the line number 13. So if I were to check my CHRC is basically, if so, if it's a, say if it's a small b, right? So my CHRC will be, is greater than A. Yes, this is true, right? This one will be also a true. So this whole statement for a small b will be of true, right? So once this is true, it does not check for this part also, because these two statements, this whole statement is actually joined with this conjunction, with my OR. Right? So similarly, if it's basically capital B, so this statement will be false, whereas this one will be a true. So a false or a true will give me a true. So this whole statement in one whole will become a true, and my CCNT will actually increase. Any question here? Any question? Please have a look at the statements and see what this works. So what about my other thing? So this one will be a if CHRC is greater than 0. Mind you, this is a character 0, okay? This is not a numeric 0. Because my input is actually a character, so I'm comparing it with the character only. And CHRC is less than equal to a 9. And num count will be plus plus. Please check for these three statements.
Sir, what about negative numbers?
I'm not considering, but my input is basically how can you give a negative number? So negative other character and a number. So my other character will be basically, you're taking an input from a keyboard, right? So you're taking in one character at a time. You're taking in one character at a time. So when you taking in one character at a time, so -1 will be actually basically counted as minus to be our other character. So my other count will actually increase, and 1 will be a number.
So it's basically a string.
Yes, you can. Let's not use the word string. Let's say that basically it's a sequence of characters.
Okay, sir.
Where each character I'm going to basically judge based on each character as it is coming. So -1, when you're giving -1, First, I'm pressing minus, which is the other character. Okay, and 1, which is another character. Okay, mind it, this is a character which I'm taking. These are not numbers which I'm taking. This getCat reads in characters, not numbers. Okay. Any question? Any question? When I'm writing this thing, please, you have noticed that how the brackets are being. So this is one statement. This is another statement. This whole thing is one statement, right? And all the statements are between braces. And these two statements are being connected with this statement and another this statement is being connected with an OR. So OR is basically double pipe. The AND is basically a double ampersand. Okay, since I do not have any other questions, so now the thing is that I want to basically do the other counting also, right? So I can do something like this, that after this thing, I can use something like else CNT plus plus. Okay, what is the disadvantage of this thing? Can anybody tell me? Can anybody tell me what will be the disadvantage of this line? What
Sir.
will be the
Sir, if there is no other character, then will the loop end?
It will actually basically go on till it does not find an UF. So until unless you do not press the key Control D or Control C, it will go on reading. So if you are working with Unix, I'll be pressing Control D for my UF statement, and if it is my Windows statement, I'll be basically pressing Control C. Then only the UF character will be generated. GetCat actually reads the UF. Okay, so the loop will continue until unless you do not press the control UF symbol. Okay. Any other question? But my question is basically any other problem. What will be the problem with my line number 17 and 18?
Sir,
Yes.
sir, when we will press the enter key,
Yes.
the other count will be increased.
The the enter is basically another character also. It's a character which is actually a symbol. So yes, in one way the other counter will actually increase. Yes. It will also increase if I've given a exclamation, full stop, comma, semicolon, right? Quotes. These are also basically characters which is going to read. So the other count will also increase over there also. So, but what about the problem with money? Is my code all right? Do you think that is going to work out? So let's take for example. So let's say basically character count. Then my number count. Then my blanks. Others. %T. Right. So this one will come to be as CCCNT num CNT BLNKCNT THCNT. Okay. So just for our advantage's sake, so what I'm going to do is basically I'm going to put card. CHRC. So I'm reading the get card. I'm going to put it by put card. Okay. So as last day, which we have seen that if you give an enter, the whole line actually basically monarchy adds up. Monarchy actually basically prints up again. So GCC CHR. Okay, so let's see. Data dot. So QWERT y $$ hash XC134. What was the space? NH. Yeah. So the characters are 23. Okay, let's make it a little bit. What do you say? Let's make it a little bit advantageous one, just not to say random characters. So happy birthday to 99 exclamation enter. Hello world. So 66 full stop. Yeah. So please note this hello world, this part is coming due to my giving an control D twice, control D once. So you have to basically not consider this line and this character, but you can consider one enter. Okay. Let's see how many I have got. So I've got how many spaces? 1, 2, 3, 4, 5. So 5 spaces with the okay. See 1, 2, 3, 4, 5, 6 spaces, right? So 6 is there. Characters, how many I've got? Blanks, how many got? Blanks I've got. So numbers I've got 1, 2, 3, 4, 5. So 5 numbers I've got. Fine enough. Let's see how many characters I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 characters. How many other characters I should be having? So there is 1, 2 over here, and there is a 3 over here, and there is 1 entered over here. So so 2, 3, 4. So but my thing is coming actually 33. So can anybody tell me why is the misnomer?
Sir, because the if is there and the else is at the last. So even if the character is a space, then also it goes on checking all the rest of the conditions, and at the last condition is also checked, even if it is a space.
I did not get it. Can you please elaborate? I did not get it.
Sir,
Sir, actually, it's counting all the other characters also, like the blank number and the number of characters.
Why?
Sir, that's
I have
Age
actually tried.
follows the immediately before
Yes.
E.
Yes,
Yes.
Only the age is following only the last E.
numbers is.
So anything other than basically number,
Is being
right?
counted in it.
It will be counted as
Yes,
basically
sir.
other order. So which is
Except
not
0
count-
to 9, any number it is counting, sir, and the characters also and blank spaces also.
No, it won't count my other num count also. If you actually see, this is basically this 33. If you see this number actually excludes my num count. So if you actually write all my characters, count my characters, you can see that my this is basically my 33 does not include my 5. Right, because what is actually happening, this becomes, if this is true, then this becomes basically false. This works out, right? Line number 17 works out. But if this is false, this counts. So A to Z to A to this thing, this even a blank, right? All these will be counted under this other count also. So these are inclusive. So I request something out. I request something way out, right? So what I'm
Sir.
going to do, yes.
Sir, can you please repeat the statement? I was not able to follow you.
Okay, let's do one thing. Okay, okay, let's do one thing. I'm going to basically increase another set of counts. So CNT will basically count all my characters, whether they are this thing, anything, right? So CNT. Okay, so this one will be anything will be basically cat CNT will be plus plus. Okay. So let's say slash n all counts equals to percentage t slash n CNT. Now let's see what happens. Let's see.
So semicolon in line number 12.
Sir, semicolon.
Sorry.
Line 12.
Oh, sorry.
Sir, in line 8 also.
Line 8 also. Line 8 to ache.
Sir, ওই other
Oh,
count
okay.
equals to 0.
Okay. So happy birthday 299 enter. Hello world 66 dot. Okay. So I've given 2 enters. Control D. Okay. So all counts does this addition actually add up actually? So 23, 5, 7, 37, does it actually add up to 42? It won't. It doesn't. Okay. So there is a problem with this, basically this 37. Because this is all right. This is all right. This is all right. So I've got 7 blanks. So 1, 2, 3, 4, 5, 6, 7 blanks I've got. No problem with that. Right. So there's a problem with this thing, this number 37. Because technically, all these 4 numbers should actually add up to these all counts. Right. So what is happening over here? Let's see. So this goes on, it's all right. This line number 13, line number 15, this is all right. Okay, so it's going to work as it is. So let's come to line number 17. So line number 17, right now CHRC, let's say if it's basically it's B, small b, right? So CHRC is small b, so this is going to become false, right? This statement becomes false, line number 17 becomes false. So my others OTH CNT will actually increase. Why? Because if each of these statements, they are actually independent of all these statements. So line number 13 is a statement which is independent of line number 15, which is a statement independent of line number 17. But line number 20 is actually dependent on the statement of line number 17. So line number 18 and line number 20, line number 18, so this is my line number 18, and this is my line number 20, which is actually dependent on my line number 17. So based on the true or the false value, my 17, my 18 or my 20 will work. Now my line number 17 only checks for only my numbers. It does not give a check for all my other things. So if it does not give a check for the other things, so my other CNT will count. So even though my characters, even if they are blanks or my even alpha, but even if they are basically characters also, they will be counted, included into this count will actually, this count will actually include over there also. So even though if it's a basically exclamation or a comma or a space or a character, other count will always increase. So this value includes, this value includes this value and my this value. This thing does not include my number. Okay, so there is a flaw in the program. This is a flaw in the program.
But sir,
yes,
even if it includes character and blank, then also the number is higher.
Which one?
Character 23 and blank 7, it should be 30. Then after that, another 7 is added to it.
But look, okay, just see that total. How many characters I have got? 42?
Yes,
Total number of characters will be 42, right? So
Yes,
there
sir.
are 23 characters. There are 5, right? So 23 plus 5 is 28. 7 is blank. 7 is blank. So 23, 28 plus 7 is how much? 35, right? 35 and 23 plus for 28, 28 plus this is 35, right?
Numbers are not included.
Which one?
In others, numbers are not included.
No, numbers are not included. So where does this 42 actually coming from? Let's see. This 42 is coming from due to the addition of 23, 5, 28 plus blank. So 35, right? 35 plus.
And say 2 enters you have given.
I have given 2 enters. So 37 plus 4 is basically exclamation. So 37 plus 4 is 41 and there is 1 full stop. So 42. Right. So my 42 is basically counted. So my others should actually include my 4 exclamations, my 1 stop and my 2 enters. So my others should actually be counted as, so 4, 5, 6, 7. We should actually have 7 over here. So if this is 7 and we add up to all these 4 numbers, then only this will be 42. So by one others is basically coming to 37. Why it is coming 37?
Sir, but numbers are not in others, you said.
No, numbers are not in others. Numbers are not in others.
20, yes,
I
23,
agree with
7
you,
and
numbers are
7,
not-
yes.
But this word, this 7 and this my 23, these are included in my 37. So how many character, how many basically exclamation character? So 4, 5, this is 1 full stop, 5 and 2, 7. 7 to 2 enters, right? So 7 plus, can you please count 7 plus 23 is?
30.
7 plus 23 is 30. And my this 7 characters, right? Because which is actually also counted over here also. So 37. So I've got my 37 answer. So my this 37 includes my characters and also my blanks. Which should actually not do. Because my others are basically, they should not be characters, they should not be blanks. Any other character which is any other character which is not a character or a number or a blank, which should be basically counted in my buses. Am I getting through you? Is there any question?
Sir, can you explain the others 37 count again, please?
What does 37? Yeah, what does 37 actually include? 37 will include my others count. Why this statement will only work if line number 17 is false. Am I correct or not? Right? Am I correct? Other count will only work only if this is basically false. Right? So when this is false, so if this is false, when it is not a number, so either it can be these things or it can be this thing also. So if this is not a number, so it can be this one also, or some other character also. So my 37 includes my 23 characters and my blank characters and also my alphanumeric characters, my exclamations, full stop, and my 2 enters which are given, which counts to 37.
Okay.
Right, which is actually not should be, right, which is not should, because others will not have these 3 numbers in these three things together inside it. Okay, any question? Any question here?
Sir,
Yes.
why is the else in line number 19 only dependent on the if statement of line number 17 and not the ones preceding them?
Why it should be? Because this is, if this statement is only true, then this will work, and if this statement is false, then only this will work. Have a look at this thing. So technically, I should have even this should have been something like this, right? If I had given braces, then I should have been doing something. If I had given braces, then I would have given something like this. So this brace is only equivalent, is only working with this if. So this is one block, whereas this is another block, and this is another block. So this else is only due to, this else is only due to this if. This else is only due to this if.
But sir,
yes,
isn't else the ending statement for the if loop? Like else is used to end the loop.
I'm actually having multiple ifs over here.
Yes. So why is it selective? Like why
Why is it
how are the loops that we have created before that?
This is
being
not a
ended?
loop. This is not a loop. This is not a loop. This is a statement. I'm checking for a statement. So if this statement is true, then do something else, then do other something else. So if the statement is true, then do something. If the statement is false, then do something. So this if is working on this condition, right? So if this condition is a true, then I'll do something this thing. But if this condition is a false, then I have to do something over here. But over here, what I had, so if this condition is true, then do this thing. But I did not have else over here. So if this condition is a false, then it will basically, what it will do? It will do nothing. It will just do nothing. It will just do nothing. If this statement is false, it will not do anything.
Okay, sir.
If this line number 18 statement is only a true, this will come to line number 20. But unfortunately, this if or this if, this statement does not instruct the system to tell you if it is a false, then what I'm supposed to do. It does not have any instruction for that. Okay.
Yes, sir.
So how do I come out of it? So obviously I can understand there is a flaw. So
Let's say if we take an if at the beginning, then
so we come out of this thing something like this. Now see what I'm doing over here. So if this condition is true, right, then do something. But I'm giving an instruction. If it is a false, then do something else. Now with an else, I'm again giving another statement condition. So else, if this is a condition, do this thing. Else, if it is a condition, this thing, then this thing. So, but then if all of these three are falses, then do this thing. So I have connected all my if statements together. So I've connected all my if statements together. So if this do this thing, then else do this thing, else do this thing, else if all of the above three are false, then do this thing. Okay, so let's see what happens. So happy birthday to 99. Hello, exclamation, word, exclamation, 66, full stop. Okay, I have given 2 enters over here. Okay, so that is why this 24 is coming out. No, sorry, my birthday spelling is wrong. Sorry. My birthday spelling is wrong. So my 5 is there, my character blanks, others are actually 7, you can see. 2 enters, 4 exclamation, 1 full stop.
Sir, why is the others count 7 here?
Huh?
Because
The others count. So if this is false, so let's see. If this is false, if this statement becomes false, then it does this thing. Then it actually checks this pass, because over here, the previously what I had done, there was basically only an else over here. But right now I'm going to connect all my ifs together. Right. So this is why I'm actually saying condition else I'm going to give another condition. Previously, if you actually see when this statement, if I actually gone to this part. So let's say this thing. See, line number 22. Line number 22, right? 23, sorry. So if this statement is true, line number if true, then only line number 25 is working. But if it is false, then line number 29 will be working. Right. So I am giving a condition right now for this line number 23. If this is a true, then do something, else it is a false. So for this, if there is a if, there is only a true and a false. But right now what I'm doing is an else if, else. Now, if it is a false, so if CHRC is a false, then this statement will be working. then my line number 19 will be working. But with this line number 19, this line number 19, with this line number 19, I'm also putting a clause. I'm also putting a proposition. So else, if this is true, then only do this thing. Else, if this is a true, else, so again, if this statement of if this is a false, then my else will be working. But with this else, I have got another if. So if this is a false again, then only this statement will be working. So I'm connecting all my ifs together. So previously for my ifs, but for my line number previously, what I had done was simply if it is a true, then do something. But with a false, I'm not telling him to do anything. But right now, I'm stating that if it is a false, if it is a true, then do something. But if it's a false, also do something. Right? But with that false, if you have to do something, you have to do the other checking also. Then give another check. So if that check is also true, then do something. But if that check is also a false, then then do this thing. But then while doing this thing, do also another check. So if this is true, then do that something. Now, since if this is also false, so if this is false, that means it is assumed that this is also false. Line number 17 is also false. Line number 14 is also false. So when I come to line number 26, if it actually comes to line number 26, it means that line number 20 is false, line number 17 is false, line number 14 is also false. Because my if then else system only works with the thing is that it will only work because if it is a true, then do something, else if it's a false, then do something. If I have only one ifs, right, I might not give a else. Sometimes I give an else, or sometimes I do not give an else. It depends on the requirement of what I am going to actually basically process. Any question? Any question over here?
Sir.
Yes.
If instead of else if we had like taken the previous one where all three were ifs, and if we had taken another conditional statement if overall, and the last statement would be else others.
No, the problem is that how will you check the overall part?
No,
how will you check the overall part?
No, if all three of like nested if we do.
Okay,
so if,
no, this is basically nested if. This is the nested if. Okay, you're talking of nested ifs. No, but if this is a false, right? If this is a false, but if this is a false, then my nested if also will not work. This problem could also have been done something this way also. I'll tell you. If you're actually looking for a this thing. This thing is also the same thing. If
yes, now not of all of these above statements.
Yeah, exactly. That is what I was doing. Right. So this is what I'm actually done. So my else part I can done something like this, right? So if this is true, then this has to be also true. This whole part. This is true, right? And this is also true, right? If all of them are true, then it will be a true. I'm sorry, there's a slight mistake over here. Sorry. This one will be, if all of them are true, no, this one will be or. Sorry, this one will be or. So if any one of them is a true, so if this is a true, so let's take for example, if this is not a blank or this is an exclamation, what's going to happen? So this is not, this one will come false. This one will also become false, right? This one will also become false. This one will also become false. So false. This one will also become false, right? So false, order false, order false, order false will give me a false. The negation of my false will give me a true. If this is a true, then only this will work. Right. So let's see. So happy birthday to 99. Right. So I have two full stops. So they have got two characters. Two others will work. So this is working. So my else can also be written as a negation of my previous statement, right? But then this is not an elegant way of working. This is not elegant. So the elegant way of basically programming is something like this. The most elegant way. There is another elegant way also. We'll get into that part later another day. So this is the most elegant way of writing. Okay. Any questions for this class? Okay, then do you have any questions? Anybody? Any questions?
Sir, can you give some questions regarding these?
I'll do it. Give me at least today. I've got an examination. We have got an examination today. After today, I'll give you some assignments. I'll surely give you some assignments. Okay.
Yes, sir. Thank you.
Yes. Okay. Then I'll take a leave then.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.